Hello everyone and welcome to the video lecture on class modeling. At the end of this session, the students will be able to design a class model for a given problem description or system requirements. In the previous lecture, we have discussed about the steps that are required for initiating designing a class model. Here today, we are going to follow those steps for a fast data incorporation example whose problem description is being given. A quick recap of what we have done in the previous video for class modeling. So how do we begin with class modeling? The first step is identifying the objects and the class, prepare a data dictionary, identify association between objects, identify class attributes and set of initial operations, and then organize the objects and classes using inheritance. So all these steps we are going to apply to a problem statement or system requirements which are being given by a client for the fast data incorporation. So here this is the way you will be getting the requirement documented or the manuscript for which the system is to be designed. I will now read out what the requirements are. So the system requirements for fast data incorporation, it wants a subsystem to process office supply orders via the web. The users will supply via web a form, their name, password, account number and list of supplies along with an indication of the quantities desired. The subsystem will validate the input, enter the order into a database and generate a receipt with the order number, expected ship date, the total cost of the order. If the validation step fails, the subsystem will generate an error message describing the cause of failure. Now, as we have seen here, our step begins to identify the objects, the classes. So how do we do? Now before we move on to identify the classes and objects, we need to understand that the class modeling will be done first and followed by the dynamic and functional modeling which will occur in the subsequent videos. Now your things that you are expected to remember is this example does not demonstrate how the technique is applied to all problems. Therefore, this is an informal strategy. So you need to be sure to distinguish between the details of the example and the details of the technique. Here our focus is on teaching the students the technique. So what is the technique? So this is basically a concise problem definition. So you are being given the problem statement. Now it is the time to define the problem more concisely. So if it is too long, you need to create a summary of it, or you need to have it in a sentence. Like you can see, we'll do it in a single sentence as it is being done over here. So it says that the fast data incorporation employees may order office supplies via web and receive a receipt confirming the order summary. So the entire paragraph what we read on the previous slide is summed up using the single sentence, which gives us a clear idea of what the system is expecting. It will order the supplies via web and in return will receive a receipt confirming the order. Now this is the first step towards identifying the classes of the subsystem. Now what is this first step? So we are going to identify the constraints governing the system. We'll be using only a single paragraph. Now this is the problem statement that has been given. Now what we have to do is we have more information to be used in identifying the classes for the subsystem. So how do we do it? We formalize the strategy. Now when we say that for this particular problem statement, we are expected to identify the nouns, okay, the nouns of the description which will serve as the basis for identifying the subsystem classes. Now you see, this is the problem statement that has been given, and from this problem statement you have to first underline what you can see as a noun. So what is a noun? Noun is a name, place, animal or thing. So if you see, and this to get this, anything of this becomes an object. So in the class modeling, the first thing that is expected, you identify either the objects, then objects together become the class. Now the question that the students face difficulty is how do they find out? So this is a strategy, it's an informal strategy which we are formalizing. So what you have to do is you have to look out for the nouns. Okay, then once you prepare the data dictionary. Now what is this data dictionary? This data dictionary consists of all the nouns. So when I say nouns, means it could be abstract nouns, it could be out of domain nouns, or it could be simple proper nouns. Okay, now let us see identify the nouns from this problem statement. So here you can see the first noun that we have identified is of employees. I have highlighted it to blue so that you will be able to differentiate what we are highlighting. So employees is identified, then you have order, office supplies, then internal web is some thing, let us name, place, animal or thing. Receipt is a thing, it's a noun. Order is a noun. Again order is coming, so here we are highlighting it. Then username, it's a noun. Then user password, account number, list of supplies, receipt, okay, order number, ship date, total cost, order, then order database, then error message. So these are the possible list of nouns that we have identified. Now what we have to do next is, once we have highlighted, I request the students to highlight or underline whenever they read the system description. So it should be a habit, or you either circle it. You can either circle it, underline it, and then once you are done, write it on the page like this. So here when you write it, you just have to identify. Now you see here internal web. Now this internal web is there. It's a noun, but are we going to code anything, or is it something that is related to designing or developing? No. So we consider it as an out of domain noun. Further, now you see this username, password, account number, order number, ship date, total cost, list of supplies, okay, item. Now this all can be considered as the attributes for that particular account or order. So therefore we consider this to be abstract. So these are abstract nouns, and once we eliminate the out of domain nouns and the abstract nouns, what we get is good candidates. Okay, so what is left with us? What are the nouns which are most appropriate for designing the classes? Is you have one is the employee, then you have the item, then you have the receipt, then you have the order, you have the order database, and you have the error message. So this is possibly the best fitted classes for the given problem description. The rest of them are either out of domain or abstract. Now what we have to do? See, we have decided not to worry about the web in this design. Instead we focus on the inputs and outputs and defer the web details until later. Now here we are very crystal clear that for the given system, the orders are coming, okay, the order is being taken and a message is returned. So out of this good candidates, now what we do is you now draw this classes. So employee class, it has attributes name and password, which is being told in the problem description. For order also, number of the account, the total cost. Then you have the order database. For receipt, you have the order number, you have the ship date, and you have the total cost. So item also, you have the name of the item, you have quantity and the price. And error message also, it's been given in the problem description that there are two possible outcomes of that is the explanation. So here you see that we have placed on the paper these classes. Now what is the next step? The next step here now is you have identified you have prepared the data dictionary, you have eliminated the out of domain and abstract nouns, you have placed the classes along with the attributes. Now the next step is to add on the details to it. Now consider over here the error message, that is the response. Since both the receipt and error messages will be generated as output, it might make sense to have them as subclasses of a more general class. So we do not know enough yet to assign its attributes, however. So response basically is an error message, or it can be a receipt. So error message can be with an explanation, and receipt as the details, like what was the order number, what was the ship date, and the total cost. Now once this is done, what we have is we give the multiplicity over here. We write down here, we join this, we give the appropriate associations. So here you see this is the multiplicity relationship, which talks about 1 plus item, then the database are connected. So this is how From a given problem statement, we were expected and we came upon building the classes, and we have now this class model along with the relationships ready. So I hope you have understood the steps involved in designing a class model. I now expect you to pause the video for some time and answer this question. So which serve as the basis for identifying the subsystem classes? Pause the video. Right answer is all of the above. Next question, attributes define properties of the object. True or false? It's true. So these are the references, and thank you for your patient listening.